Okay. Hi folks, good afternoon. It is about 1 minute after 2, so sorry I had a little technical difficulty to start everything out, but I'm really glad you joined me today in this very informal weather chat. I do want to give you one quick heads up in case you missed the news just now. The state superintendent is applying for a federal waiver to cancel SOLs, so we'll see how that goes. I don't know how official that is yet or what's going to happen, but my guess is that may be happening, which I think is good in some cases and of course bad in other cases. But that would relieve some pressure from the teachers in many cases and from students, especially your algebras, your geometries and algebra 2s and some of those upper level or high school mathematics. So we'll see what happens with that. So they're applying for a federal waiver to cancel SOLs. I remember this time of year, I was pretty much wrapping up my earth science SOL. Let me just give you a quick background on my teaching experience. Of course, I've been a meteorologist since the 90s on television, but
The 90s?
The 90s, Scott. Oof. The 1890s. No, the 1990s, of course. And I took a break to teach, and I taught high school at Powhatan for 6 years, Powhatan High School, Earth and Space Science, and then I also taught a meteorology astronomy course for juniors and seniors. And then I came back to doing this, and they're allowing me to teach as well. So I also teach now at Elsie Bird in Chesterfield. Just one class a day, but it's every day, and it's second block, and it is for juniors and seniors, and it is a semester of meteorology and a semester of astronomy. So I have my endorsement in the earth and space sciences. So I could teach astronomy, meteorology, geology, I said astronomy, didn't I? Oceanography, any of the earth sciences. I did say geology. Okay, here's what I want to do today, and I got some questions from folks, and that kind of gave me an idea and a plan on what things to cover. I'm going to start out with some weather things. Well, a lot of folks, or I should say two, not a lot, asked to explain the relationship between temperature and humidity and how that plays into our forecast. And a question about pressure. Hey, I do want to thank Tammy Bartlett, a middle school teacher down in Dinwiddie, and she's the one who kind of got the ball rolling for me with these great ideas to do this. And one other quick housekeeping note before I get started. I've been in touch with the Math Science Innovation Center. The Math Science Innovation Center used to come out, and I think they still do, when I taught in Powhatan, they'd come out and give demonstrations and hold a whole class for you. And from top to bottom, and it'd be a great teaching tool. And that was always an SOL-focused demonstration and lesson they would do. So let me see if I have Carol Ellis. Yes, he said he may come out. Maybe next week we'll do some stuff out in the Backyard Weather Center, some demonstrations and more talk on these type of sciences. Okay, so we'll see how far this goes, and if there's a demand for it, we'll do it every few days.
There's 10,000 people watching right now.
10,000.
10,000. Lots of pressure.
Now I'm nervous.
All the kids across America are watching.
Well, good. I hope that you're making this a part of your lesson plan. I know you have to come up with these crazy lessons, and the kids doing them or not, and you could just give them the link, and they can watch me, and this hopefully will cover your whole week.
Let's do this.
Let's do this, Scott. Okay, first question I have that I want to talk about is the relationship in meteorology between temperature and humidity. Humidity is one of these things that you can't see, and certainly you can feel, correct? When the humidity's high and the temperature's high, the dew points are high, and you just feel kind of sluggish. It's those days, believe it or not, where the air is actually a lot lighter. The more humidity, vapor is lighter than all the other elements in the air. So that causes air to rise. And that's why we get these big thunderstorms in the hot, humid environment. Scott, if we can focus on our big 9 monitor there. Folks, look at this. We are at 87 degrees right now. This is the current temperature. That's a big temperature. Our humidity is 37%. So what I want to talk about is the relationship between these two numbers and how they work together. So what the temperature is, the temperature represents a volume of air. Hot air expands, cold air contracts. That goes for many things in science. Hot expands, cold contracts. So the warmer the air, the more the air expands. The air molecules push outward. That creates a bigger volume of air. So if this cup represents my volume of air, let's say at 87 degrees, if our humidity is 30%, that means my volume at 87 degrees is about 37% full of vapor. So that is what our atmosphere would look like right now if it were a cup. 87 degrees, 37% humidity. It's relative, it's related to the temperature. That's how we get our relative humidity. Of course, when our humidity rises, it's going to be more humid and muggy and so on and so forth, and you're going to feel more pressed and more down and more hot. That's when we start talking about things like the heat index. So what's going to happen then later today? Well, our volume is going to shrink because we have a cold front that's going to come through the area. So that's going to take our air and contract it to a smaller volume. So let's say later now, tomorrow or tonight, our volume is going to shrink to 55 degrees or something like that. So our volume gets smaller, but our vapor isn't going anywhere. So our humidity will probably rise to close to 90 to 100%, and that will kick off some rain showers for us. Once this overflows or once it gets full, the air is saturated and you're gonna get some rain. So by getting rain, we gotta take the volume of this air, cool it to the dew point, 58 degrees. So if this volume is 58 degrees, we're gonna start to get rain. So we're gonna press or contract the air later with cold air coming in. That's basically how you read something like this, 87, 37. So this volume, 37% full. If you were to think of this as a cup or a cylinder or something like that, any kind of volume, 37% full. Once this gets to 60, 70, 80%, you know it's pretty darn humid out there. All right, does anybody have any questions or anything on that?
There's a question.
Yes.
Because everybody thinks that Virginia and Richmond is a very humid climate. How does the geography of the state or the city play into that?
The geography of the state
like,
or the city.
I suppose like Arizona is not humid, let's say, but
Correct.
Virginia is humid.
You know, that's funny. I think of Virginia sometimes as very dry. Yes, it does get very humid, but I think we tend to get dry sometimes too. We tend to get very dry, especially in winter. We get these cold air masses that come down that are very, very dry. This is a good example right here, Scott, if we can show you that map, and I'll explain that quickly. And that's a good question. Yeah, it does get hot and humid here, and you sweat like crazy, especially in July and August, but I think there's a big dry season too. So what I'm going to do is I'm going to switch to air pressure and how air pressure controls all that. So let's ignore that rain and stuff on that map, and let's say we've got a big area of high pressure that is right in the center of the country up there. Hold on, be patient while I try to do this without my glasses. Okay. So when high pressure is there, you're going to get clockwise winds around high pressure. It's called an anticyclone. Many of you may have taught this as an anticyclone, and you get these, ooh, that's a bad map. Hold on a second. Clear last illustration. Bear with me.
If you guys have any questions for Tom about earth science or the weather, this is a good time to ask as he's getting his graphics together. Okay.
So oftentimes in winter we get these cold high pressure systems. Now cold air is heavier air. It's more dense. That's why it spills down out of the Arctic. So high pressure means heavier air or more dense air. So with it you get these cold breezes out of the north, and typically these are very dry air masses. This originates over a continent up here. So it's dry air. It's called a continental polar air mass or a CP air mass. Well, sometimes that same high pressure system could kind of change up on us. Now let me show you why here. Clear, clear, clear. Once that high moves over, say in this area, well, you still get the clockwise winds, Scott and folks. Blue jet. But now that air, oops, that's high again. You know, I'm trying to do this without my glasses, Tom. Just wear your glasses. Yeah, there you go. All right, so now what's going to happen is the clockwise winds are going to come off the ocean. And now the dry air mass that we had when this high was here, the high has moved here, and now warm ocean vapor is going to come in, and we're going to get that cool maritime polar air mass. Maritime meaning it originates over an ocean. So we're going to get very humid in this situation, and this often sets up a situation where we're kind of cold and cloudy and drizzly for a couple days.
We have a star student, by the way. Tammy Bartlett.
What's that?
Tammy Bartlett.
Yeah?
She said ocean breezes have a role to play in all this before you said it.
Oh, really?
Before you said it.
Oh, well, thank you, Tammy.
She needs to be advanced, I think.
Tammy, I usually go to her school, and I didn't get a chance to this year down in Dinwiddie. And that's another reason why I'm doing this, folks, is because we can't do schools now. It's suggested that we don't go, plus you're not in school anyway. So I thought this would be a good idea just to do this like that. Yes, Tammy, very good. Yes, ocean breezes are going to increase our humidity, but it's simply from the high going from here to here. So we'll be dry within a day or two. We'll be very humid, and our air changes that quickly like that. Okay. Any other questions at this point? And I'll move on.
They're more general, unrelated to the specific topic at hand.
Like, why didn't it snow this year?
Caleb wants to know what the hottest place on Earth is.
Oh, man.
Isn't that Death Valley? Does that sound right?
Death Valley's probably the hottest in the U.S. Yeah.
Okay.
Death Valley will get well into the 110s almost every summer. Sometimes
Karen Smith says you should be a teacher, Tom. Tell her what you are, Tom.
I do teach. Did you just join me? Were you late to class today?
Karen needs to go to the principal's office. She's late to class.
Karen, I teach a class right now at Elsie Bird High School.
And Sylvia wants to know why tornadoes seem to form in the Midwest.
Sylvia.
Maybe that'll be next week's class, Sylvia.
Yeah, there's a lot of information.
Come back next week.
But I can do a quick and easy on this. So what you can do, a tornado in many of the formations, you're going to get this warm, what they call like a low-level jet stream. So you're going to get warm, humid air coming out of the Gulf. Look at Gulf, humid, right? That would be our tropical or maritime tropical air mass is going to come up. And that low-level jet kind of supplies a lot of moisture and humidity. But we're also going to get, and these are why these often happen in spring or our transition seasons, it still wants to be winter, so I don't like that little arrow. Hold on. This one. This one, the bigger one. Hold on.
While you're doing that, Ms.
Yes.
Bartlett says Ethiopia is arguably the hottest inhabited place on Earth.
I believe you, Tammy. I believe you. So you're still going to get these cold, dry, continental polar air masses, and you're now starting to get these warm, humid, maritime tropical air masses. And these create different level wind patterns in the atmosphere. You get wind shear, and you get rising air, and you get violent thunderstorms. That's generally why it happens in this part of the country. First, their geography, look at that, they're open to the Gulf, and they're open to the Arctic too, and that's why this whole area is known as Tornado Alley. It's open to two very contrasting air masses.
Good question. Good answers. I'm learning today. All right, we got about 5 minutes left in class. So
We do?
I mean, if you wanted to go 20, we got 5.
Oh my gosh, that went too fast.
Well,
All right, let me just do one quick demonstration. This is more of an earth science demonstration. And my friends, and you can do this one at home, like if you're homeschool or anything like that. The kids are bored. This I learned from the Math Science Innovation Center when they came to my class one time.
where should I stand for this? I don't want to get burned or...
You're not going to get burned.
Okay.
Okay.
I got
All right.
6 feet away,
This
too.
is cool. This is how sinkholes form. You know sinkholes? Oftentimes you hear about a house caving in down in Florida. Or oftentimes, maybe you've been to Luray Caverns or any of the caverns in Kentucky or Ohio, one of those areas where the caverns are. Has anybody been to a cavern? A few of you, Luray? A couple of you, good. Well, this would be a sinkhole, so this would be more like Florida. Underneath the ground in Florida is a lot of limestone. And limestone is a type of rock that dissolves easily dissolvable rock. And that is underlain in much of Florida's ground or surface. So I got this little Monopoly hotel, and again, I got this idea back from the Math Science Innovation Center. I'm a little nervous. It's easy to do when like 1 million people are watching, but 10,000?
Well, it's only 8,000 now. We lost about
I bored
2,000.
them. That happens in class. Usually about 20% fall asleep, so good job, folks. So, in the atmosphere, we have air, right? We have, you heard of oxidation, when things rust, when moisture and oxygen mix. Well, we have small amounts of carbon dioxide in the air, and that carbon dioxide mixes with rainwater and creates a weak acid called carbonic acid, carbon dioxide acid. And that weak acid sinks into the ground in rainfall. And over time, now Scott, this is going to take a while, so don't expect miracles right now, folks. Over time, that seeps through the ground and causes our limestone to dissolve. I would have to do this for about 10 more minutes. But we'll just kind of leave it there. And if you start to see, maybe quickly here, maybe not so quickly, maybe we'll kind of dump a little more water. Let's do a deluge. Let's do a Richmond rainfall here.
It's like Gaston.
Yeah, let's throw Gaston on him. All right, so what's gonna happen here, and usually this will take a few, like 10 or 15 minutes. That's why this will kill some quick time for you at home, is that sugar underneath, AKA limestone, will start to dissolve. And if you come back in about 20 minutes, that house, the foundation, will either be tilted severely or sometimes completely dissolves and it sinks into its own sinkhole. This would be a great thing for you guys to do at home. Teachers, students, homeschoolers, sugar cubes. In fact, I went to Wegmans today. There was a run on sugar cubes. No, there wasn't. But make a run on sugar cubes. Everybody's getting sugar cubes. Can you imagine that? Toilet paper and sugar cubes. Anyway, there were plenty of sugar cubes. So this would be great, and this only takes a quarter of a box. It was like $1.99 or so for the box of sugar cubes. So this will eventually dissolve, and we'll lose our foundation to the house. Scott, I'll come back to that in a few seconds. Let me just show you what I'm doing in my class right now. We'll make this quick. A couple more minutes. Let me log back in.
Oh, well, I all know your password now.
That's all right. These are some great resources for astronomy that I like to look at. First of all, what I'm teaching, since I teach astronomy right now to 11th and 12th graders, and one thing we're going over is, what did I do with it? Not that. Yeah, no, not that, that's me. No.
That was weird.
Yeah, right?
Talking to you.
This is it. This is our solar system. Now, what blows everybody's mind is there are trillions of stars, right? Trillions upon trillions of stars. And each star has its own solar system. Isn't that crazy? Which means that there's
wild.
How many trillions of planets and comets and asteroids and all that junk, right? Or our own solar system.
Do you have a favorite star, by the way?
Not
the sun. Sun doesn't count.
Really?
No, it's too easy.
Sun's the only one I know. The only one I've spoken
You teach astronomy, it's the only one you know.
No, I don't have a favorite star. Okay, I have a favorite star. I like the hyper blue giants. All right.
In general.
There's a whole class of hyper blue giants that are enormous stars that are like thousands of our suns. And they're the biggest, brightest, hottest stars.
The more you know, kids.
Yes, I think the blue stars are cool. Okay. Anyway, believe it or not, what we like to study, or what I like to study, is where does our solar system end, right? So here's our sun, Earth, and all the planets and so forth. There's an actual end to it. And what happens, and we know this because of the Voyager spacecraft. The Voyager spacecraft was sent out in the 1970s, 1977. And it's still going, Scott and people. And it's still out there. And it's left our solar system, the Voyager 1. And we can tell because the solar wind, or the plasma, is no longer being recorded on it. So there's no more solar. So our sun no longer has an effect on it. So they approximate our solar system to end about 11.5 billion miles radius to the sun in all directions. 11.5 billion miles alone will be just our solar system. And so they find out these little areas called the termination shock, where the sun's plasma slows down, the heliosheath, and then the heliopause would be the very last portion of our solar system. It's called the heliopause. Once you leave the heliopause, you're in interstellar space. I think that's a really cool thing, especially that, again, trillions and trillions of solar systems out there, each with their own heliopause. But this is our man-made object, is the farthest thing ever gone. It's called Voyager 1. Another thing that we'll be starting here in my class is the Parker Solar Probe. This is on NASA's website. It's a probe that they sent to the sun about 1.5 years ago. It's still on its way. There's great videos to watch here. There's great images and explanations on how they made this thing. And its voyage to get as close to the sun and get as much information on the sun as anything we've ever sent out there. And there's even a great thing about its heat shield and what it's made of and how thick it is to get this thing to survive its mission to the sun. And it's using the planet Venus as an assist. So it's going to go around Venus and kind of get slingshotted back.
Like roller derby.
Yeah, several times, like 20-odd something passes of the sun it's going to take. So once this thing gets going, this will be big news. So it's called the Parker Solar Probe. Parker was a big scientist, I think in the 50s, who studied the sun. And these are great. And you can get all these websites. There's a solar system. let me see. These.
Do you have a favorite planet? Since you kind of
Neptune. Love me some Neptune.
Why
Again,
is that?
it's blue. I'm into the color blue. I think.
guess so.
It's got a big blue spot on it.
I was kind of shocked when I was teaching my kids earth science at home homework that Pluto is no longer a planet. That kind of messed me up a little bit.
Well, they called it a dwarf planet.
I know, but like growing up, it was always Pluto was the last one out
You know
there.
what? Just between us, Scott, go for it. Call it a planet if you wish.
All right, my kids
It's
might get a bag.
planetoid, which means
That wasn't even a word when I was learning it.
Well, here's a few things about it. Okay, so the first 4 planets are the terrestrials or the rocky planets, and then you get into the gas giants, right? The big supergiants. Then you get Pluto, is not a gas giant.
Right.
So you got to go back to being a terrestrial kind of thing again. So they didn't like that. They didn't like its orbit. It had a funky orbit.
What I'm saying is you shouldn't have called it a plane to begin with. I mean, whoever made that initial call screwed up.
Right?
I think.
Yeah. Well,
Anyway.
I think that was back in the 30s or something. I don't remember
All
exactly.
right, I'm going to go through these comments one last time. Let's see. Betty or Caleb wants to know what your degrees were. This is Caleb in Woodlake. What are your degrees in? I guess he's questioning, or perhaps just wants to know your
No, to do this,
your credentials.
Meteorology. I also have a teaching. I don't think I got a degree in teaching, but I had to take a lot of coursework to teach from meteorology. Do you know what I mean?
Yeah.
So I had to prove that I took all these classes in science to get a teaching license, but then I had to take several other like how to teach and all that kind of thing.
Carol Ellis Jr. says, "Thanks for the plug. Underground escapades is the lesson."
Oh, it is? Let's see how it's going over here. Our underground escapades. All right. Our house is beginning to lose its foundation. Look at that. It's tilting and it's sinking. Can you tell?
Well, now I can. 'Cause you just pressed it down.
Well, I'm doing this in lieu of time, but you can see how it's starting to sink. And our
We got all the
sugar.
time in the world, man.
Oh, you do?
I mean, school's not going
All
to...
right.
I'm not going to say school's not... Whatever. I'm not going to say that on this.
I gotcha.
School's going to be out for a while.
Well, we are losing our house here, so our sinkhole is beginning. Carol Ellis, Underground Escapades. Carol, I used to run into him. He used to come to the guy across the hall from me. And I'm trying to get him out here next week. We can go to the backyard weather center and do this, Scott, if you don't mind.
I would love to.
And he wants to do a demonstration on the whole rock cycle.
So, last thing, and then I'll take it back to work. Tammy wants you to say, this was great. She thanks you for your time and wants you to put all those links in the Facebook post so people can find them. Ha ha!
Okay, Tammy. All what links? All these things that I'm.
Yes, all those links that you just blew through.
Okay.
Just copy paste
Just
them.
copy and paste.
Yeah, it's that easy.
Scott is our internet guru here, so I come into him with the most basic questions.
Control C, Control V. You got it, brother. All right, I think I heard the bell ringing.
All right, yeah, the bell's ringing, folks. Let me know if you need a pass. I'll write you a pass. Tell me.